What is analytical chemistry? Analytical chemistry is the science of obtaining, processing, and communicating information about the composition and structure of matter. It is essentially the detective branch of chemistry, focusing on identifying what substances are present in a sample, which is qualitative analysis, and determining exactly how much of each substance is there, which is quantitative analysis. But what about volumetric analysis? Volumetric analysis is quantitative analytical technique used to determine the concentration of a solution by measuring its volume. It involves carefully adding a solution of known concentration called titrant to a known volume of the solution being analyzed called analyte until the reaction between them is complete, indicated by a color change or other observable endpoint. Qualitative analysis determine the presence and specific types of organic acids. For example, citric, malic, tartaric or ascorbic acid. As for quantitative analysis, total titratable acidity via acid-base titration to calculate the total organic acid concentration. Acid-base titration is a fundamental analytical technique used to determine the unknown concentration of an acid or base. It works by performing a neutralization reaction where a measured volume of an unknown solution is gradually mixed with a standard solution of known concentration until the reaction is complete.
Hi, now I'm going to explain about the background application of acid content in commercial fruit drinks. First, what is citric acid and why is it important in commercial fruit drinks? Citric acid is the main organic acid found in citrus fruit such as orange and lemons. It is widely used in commercial beverage as an acidulent to enhance flavor, improve stability, and adjust pH. This acid balances the high sugar content in fruit drinks to prevent them from becoming cloying. They mimic the natural sweetness of fresh fruits and make the juice more juicy and refreshing on the palate. Next, acid also helps to prevent discoloration, such as the browning of apple juice and degradation of vitamins by binding to trace metals that trigger oxidation. Lastly, by lowering the pH, acid also helps to create an inhospitable environment for sporish bacteria and yeast, which helps to extend their shelf life.
Did you know that the principle of acid and base titration can be divided into three, which are this, and this. So, in this video, we are going to do a titration experiment to determine the content of citric acid in lemon juice with sodium hydroxide. So, 1 mole of citric acid will react with 3 mole of sodium hydroxide and it will produce 3 mole of water and 1 mole of sodium citrate. So, in this experiment, indicator that we use is phenolphthalein. So, what is phenolphthalein? Phenolphthalein is the classic acid-base indicator and pH indicator that both used in laboratory and industrial. So, why phenolphthalein is important? So, phenolphthalein serves as a fundamental acid-base indicator in titration. So, do you guys know what is an endpoint? Endpoint is when an indicator shows that enough reaction has been added to a solution to complete the reaction. This indicates the change of color or intensity.
Okay, now I will explain the experiment of titration between citrus acid, which is lemon juice, and sodium hydroxide. So, the first thing that we need to have before we start the experiment is the chemical reagent and apparatus, which are sodium hydroxide solution, diluted lemon juice, phenolphthalein indicator, burette, pipette, conical flask, white tile, and retort. Okay, the first thing that we need to do is setting up like this diagram. Okay, next, we need to rinse the pipette with distilled water and rinse again with sodium hydroxide solution to the burette and let the solution run through the burette pipette to a waste speaker. Complete this action 3 times. Okay, now using a pipette, transfer 20 ml of dilute lemon juice to a clean conical flask and then add 3 drops of phenolphthalein indicator. Next, fill the burette with sodium hydroxide solution. Let some of the solution run rapidly from the burette to expel all air bubbles from the tip. Add more sodium hydroxide solution until 0 ml marking. Okay, next, place the conical flask under the tip of burette and place the white tile under the flask to make it easier to see the color change from colorless to pink. While continuously swirling the flask to ensure true mixing, run the sodium hydroxide solution from the burette. Continue add sodium hydroxide solution drop by drop until the color change from colorless to pink. Read the final volume of the burette and write the volume of the sodium hydroxide used in your data table. Lastly, refill the burette with sodium hydroxide solution and repeat the experiment 2 times. And you are done!
This slide shows the example results obtained from the filtration. 3 filtration trials were performed, giving an average filtrate volume of 17.60 ml. Using the standardized NaOH concentration of 0.100 mol, the mole of sodium hydroxide were first calculated. Based on the balance equation, we can see that 1 mole of citric acid reacts with 3 moles of NaOH, so the mole of citric acid were determined. The concentration of the diluted juice was calculated as 0.0235 mole per liter. After correcting for the 10-fold dilution, the estimated concentration of citric acid in the original juice is 0.235 mole per liter. So, what is the importance of volumetric analysis in food and beverage industry? The first one is quality control. This ensures food and beverage products meet quality standard. It also maintains the color, taste, texture and composition across the product batches. The second one is determination of acidity. By conducting a volumetric analysis, the acidity of a product can be measured. This helps in maintaining the desired flavor and product stability. Next is food safety. Volumetric analysis can help detect insufficient or excessive level of acid, salts and preservative. This helps to ensure the product are safe for consumption. And the last one is shelf life assessment. Changes in acidity and other chemical properties during storage can be measured by volumetric analysis. This can help the manufacturers to determine the stability and estimate the expiration date of the product. In conclusion, volumetric analysis is an important analytical technique because it provides accurate and reliable results for determining the concentration of unknown solution. It is widely used in food analysis, pharmaceutical manufacturing, environmental testing and quality control. Its accuracy and simplicity makes it an essential method in analytical chemistry.